Hello. So we've been talking about the chain rule a lot, but to kind of drive the point home about the actual process involved, and it isn't actually that complicated, but when written with the terminology and or expressed purely with mathematical words, it can be a little bit convoluted, I think. So what I was going to do is just take the derivative of these 5 functions, and hopefully you can kind of see what I'm doing, because the functions are all very similar except the coefficient on x inside the function. So that inner function is different, but the outer function is really the same. So I'm going to find f prime of x, and that's going to be equal to the derivative of the outer function with respect to the inner function. And you can probably already tell what the derivative of this one is, but we're saying that that's going to be equal to cosine. It's going to be cosine of x times the derivative of the inner function times 1. Okay? That's just going to be cosine of x. All right. What's g of x? What's g prime of x? Let's do g prime of x. G prime of x, on the other hand, is going to be equal to, well, what's the derivative of the outer function with respect to the inner function? Well, that's cosine of 2x times the derivative of the inner function with respect to x. So times 2. It's going to be equal to 2 cosine of x. And you probably, 2 cosine of 2x. It's one of the most important things to understand. 2 cosine of 2x. And you probably recognize that from the last video. Now how about h of x? You probably notice a pattern emerging. H prime of x is equal to, well, we're going to take the derivative of the outer function with respect to the inner function, where we essentially pretend that the inner function is just x, and then we plug it in later after we take the derivative. This is just going to be cosine of not x, but cosine of 3 of x, right? Because we plug that inner function in, but we ignore it at first. Then we multiply by the derivative of the inner function with respect to x, which is 3. So that's going to be 3 cosine of 3x. Cool. Now what about I? We have the function I of x. And I isn't a letter that I use very often for functions, but I prime of x is going to be equal to, well, we're doing the same thing again, right? Derivative of the outside function with respect to the inner function. Cosine of 4x times the derivative of the inner function with respect to x times 4. It's going to be equal to 4 cosine of 4x. Okay, last one. Hopefully this is starting to become clear what I'm doing here. J prime of x, and that's not really quite a beautiful j, but I'm going to go with it. Derivative of the outer function with respect to the inner function. So we take the derivative of the outer function, which is, sorry, I'm doing this all wrong, which is cosine of x, but we're taking it with respect to the inner function. So instead of x, we have 5x, and then we multiply by the derivative of the inner function with respect to x, which is going to be 5. So this is going to be equal to 5 cosine of 5x. So hopefully, when you see how these connect here, there's a pretty clear pattern, right? Hopefully you notice that pattern, how all we're really doing is taking the derivative of the function as if it didn't have an inner function except x. So we're pretending that all of these are sine of x. But then after we take the derivative and find cosine of x, we're plugging in what the inner function actually is for x. So we have, the inner function actually is x in this one. In this one, it's 2x. In this one, it's 3x. In this one, it's 4x. This one is 5x. But then we also have to multiply by the derivative of the inner function, which is going to be 5, 4, 3, 2, and 1, which you can't see here, but it's there, because the 2x, the x, 3x, 4x, 5x, etc., those are all linear functions. So the derivative of those functions will be a constant, and it's going to be that coefficient, the slope. So hopefully just seeing how I mechanically did this, how I just took the derivative of the outer function, plugged in the inner function, multiplied by the derivative of the inner function, you can tell, despite all the kind of confusing words and perhaps notation, what exactly I'm mechanically doing when I'm using the chain rule. So this is going to be the final example for now with the chain rule. Well, not the final example using the chain rule, but the final example using kind of exclusively the chain rule for the chain rule's sake, let's just say. Anyway, I hope this cleared a little bit up, or at least helped you get a better idea of the chain rule, and thanks for watching.